Hey everyone, welcome to this series where we build a 2D glove simulation from scratch. Just JavaScript, a canvas and some math, and by the end you'll have a glove you can grab, drag around and tear apart. In this first episode, it's all about project setup, the game loop, delta time, drawing to the screen, and mouse input. Let's get into that. So let's jump into the main HTML file first. Because this is the file that actually runs first too. We've got a canvas element. This is 1280 by 720 pixels, so basically 720p. There's a light gray background and a thin black border, so we can see where the edges are, and that's really all we need for the canvas. Then we load two scripts, background and our simulation, and below that that we get into the actual JavaScript. Here we grab the canvas element and get a 2D drawing context. These are global variables on purpose. We use CDX all over the place to draw stuff. CDX just means canvas context. So it needs to be accessible everywhere, right? It's definitely not the cleanest pattern, but it works for this tutorial. It's really simple to use, and that's my main point here. Then one more important part, the game loop. We've got three variables for timing. Last time stores when the previous frame happened. Current time is when the current frame is happening, and delta time is the difference between those two. Basically, how many seconds passed since last frame. And that's the loop itself. We use request animation frame to call main loop over and over again. Every time it runs, we measure how much time has passed. We convert it to seconds by dividing it by 1000, and we pass the delta time into update background. Why do we care about delta time? Because your computer and my computer don't run at the same speed, obviously. If I just move things by a fixed amount every frame, then someone running at 144 FPS, for example, would see everything move way faster than someone running only 30 frames per second. And that's of course not that's not usually what you want. Of course, you can also set it for you can set the delta time with 0.001, for example. This is totally up to you. Actually, I like to use static delta time for my fluid simulations because it is way more controllable. But yeah, for this tutorial, we will use the delta time. And then we have update background. This is super simple. It calls update, then it calls draw. So every frame we update the state of things and then draw them. Let's take a look how we can get the mouse position. For this, I have a method called get mouse pos. When the browser gives you a mouse event, the coordinates are relative to the whole page, but we don't care about that. We need coordinates relative to our canvas. So we grab the canvas bounding rectangle and subtract its top left corner from the mouse position, and then we get mouse coordinates that actually match up with what we are drawing. Then we have got three event listeners: mouse move, mouse down, and mouse up. They all convert the position the same way, and then they forward it into the background. The background decides what to actually do with the mouse input. Main HTML doesn't really care. It just passes messages along, and right now these just log stuff to the console, well, the background and so on. But later, this is how we will grab mass points, drag them around, and so on. And then we have the background.js file. This acts like a middle layer. It is like sits between everything. In the constructor, it creates a simulation. Then we have update and draw methods. So yeah, they are also called. They are also calling the simulation. So right now it's literally just forwarding everything. You might be thinking, why not just call the simulation directly from main HTML then? And you could do that, of course, but later we are gonna add mouse interaction, glove setup, point selection, and all of that goes into Playground. So it makes sense to have it, even if it's kind of boring right now. The mouse handlers also just logged to the console right now. We're not doing anything with them yet, but we will need them soon enough. Okay, and then simulation chess. There's really not much going on here yet, like in every other file. We have an empty constructor. The update method just logs to the console because we don't have anything to simulate yet, and the draw method just paints a small red rectangle on the canvas. The reason that the rectangle is there is just so we can open this in a browser and go like, okay, there's a red square, it works. Because if you can't even draw a rectangle, you've got a problem somewhere, and you want to find out how you want to find that out as soon as possible. Not like 5 or 6 episodes in the simulation or somewhere. That happened to me quite a lot, so I always make sure first that I can actually draw something onto the canvas. And yeah, that's everything for now for the project setup. 3 files, main HTML, has the canvas, runs the game loop, playground, owns the simulation, will handle input later, and simulation is where the physics and the drawing will go. In the next episode, we're gonna add a vector2 class, because once we start doing physics, we need to add vectors, subtract them, get their length, normalize them. We do that constantly, so having a proper class for that is gonna save us a lot of headaches. We will also start passing mouse positions and vectors instead of separate x and y values. And yeah, that makes things also easier. And then after that, we will get into drawing utilities, then mass points and verlet integration. So that's the things actually start moving on screen. Yeah, so stick around for that. That's gonna be really, really fun. Okay, and that's episode 1. Thank you for watching, and I will see you in the next one. And by the way, sorry I forgot that. If you want to follow along, all the code for every episode will be available in the description. There's a link. There's code for every episode, and if you have problems, you can compare your solution and the working solution, and yeah, test around, check stuff, and so on. Okay, so now that's everything now. See you in the next one. Bye bye.